Welcome guys. So in this video we prove three simple formula. Now one is the k from 1 to n. This is n times n plus 1 divided by 2. And another is k squared k from 1 to n, which is 1 squared plus 2 squared plus n squared. This is n times n plus 1 times 2n plus 1 divided by 6. Okay, so I guess in this video we just only try to prove these two. And there are various ways to prove it, so let me do case by case. So the first one, I can denote that as 1 is 1 plus 2 plus n. Okay, so this is arithmetic progressions. So basically you can just if you try to do this, then you can use the arithmetic progressions formula to prove it. Okay, and but another easy way is that you just follow that as n, you just write down as 1 plus n minus 1 up to 1, and then you add 2 of them. So you get 2 as n is just n plus 1 plus n plus 1 plus n plus 1. Then the total you have n times n plus 1. So you get s of n, you just n plus 1 divided by 2 Okay, so this is the first one. And there is a second one, and I guess there are multiple ways to prove this formula. The easiest way is that you can use the mathematical induction. So let me try to do this. So we assume that this is correct. So for n equals to 1, the left hand side is 1 squared, the right hand side is 1 times 2 times 3. Okay, so this is correct. And suppose n equals k is correct, then for n just equals to k plus 1, then what we can write is 1 plus 2 plus 1 squared plus 2 squared plus 3 squared up to k squared k plus 1 squared. And from the point of view, this is k times k plus 1, 2k plus 1 plus k plus 1 squared. Okay, so we can get k plus 1 out, then we get 6k to k plus 1 plus k plus 1. So get k plus 1, so this is 6. So we have 2k squared plus k plus 6k plus 6. This is k plus 1 times 2k plus squared plus 7k plus 6 divided by 6. So this is 6k plus 1, and you can check this. Should be this is 2 and 3. So you see 2 times 2 plus 2 times 3 is 4. 1 plus 1 times 3 is 3. So 4 plus 3 is 7. So this can be written as k plus 2, 2k plus 3, k plus 2, 2k plus 3. And this is just 6k plus 1, k plus 1 plus 1, 2k plus 1 plus 1. Okay, so we prove that n equals to k plus 1 is correct. Okay, so from all this, we prove the theorem. Okay, so this is for this video, and very elementary, and I will see you guys in the next videos.